Hi, my name is Chima, and today I will be solving Leetcode problem 121, best time to buy and sell stock. A very classic Leetcode problem, so let's get to it. So for this problem, we're given an array prices, where prices at index I is the price of a given stock on the ith day, and we want to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And at the end, we want to return the maximum profit that we can achieve from this transaction. If we can't achieve any profit, return 0. Example here, we're given an array prices of these 6 numbers, and we output 5 because the maximum profit that we could buy is or rather the maximum profit that we can achieve was if we were to buy the stock on the 2nd day and sell the stock on the 5th day. And as you can see here, that's their explanation. And on the contrary, on example 2, we're given an array of prices of these 5 numbers, and in this case there are no possible ways that we can buy and sell stock in a way that we can achieve profit, because as you can see, all the numbers are essentially sorted in descending order. Thus, it's not going to be possible to achieve any profit. So in this case, we just return 0. So that's basically the explanation of this question. And I'll first start off by explaining the naive solution, and then explaining a more optimized version of the solution, to show how you can progress to solve this question in a more meaningful way. So for the naive version of solution of this question, we can see that we have an array prices here, and our goal is to maximize our profit by choosing to buy stock on a single day and choosing a different day in the future to sell that stock. So if we were to have a nested for loop where our outer for loop represented our past day or previous day, and our inner for loop represented all future days, then we could check all possible combinations in our array to see the best way that we can maximize our profit. So to put it in layman's terms, our outer for loop would be our buy, and our inner for loop would be our sell, because our inner for loop represents the different day in the future that we would wish to sell that stock. And that is a good solution. That would work, that would pass. But the problem with that solution is that it's an O of n squared solution because we're using a nested for loop. So a better solution here was if we were to use the sliding window technique. So the sliding window technique just involves us increasing or shrinking our window based on particular conditions. So in this case, for example, in input 1, we can have our window start off at size 1, and then we basically want to increase our window if we know that the price at a subsequent day is greater than the price at the current day. Why? Because that means that the price of the subsequent day has a possibility of us attaining a maximum profit or attaining a greater profit than we could have had if we were to shrink the window. So that's essentially the conditions. And on the opposite side of things, we want to shrink the window if and only if the price on the subsequent day or on the following day is less than the price of the current day. So for example here, let me just go into Paint and I'll show an illustration of what I mean. So now this is basically what the sliding window technique entails. So we're going to start off with our window like this. So it's going to be our low, going to be our high pointers to indicate our windows. And as I said, we want to increase our high pointer if and only if the subsequent element is greater than our current element. So in this case, when we start off iterating through our input, you see that we're currently still at the same element, so we can just shift our high pointer to here and we make that check, right? In this case, our value at high is less than the value at low, so what do we need to do? We need to shift our low pointer to where high is. So to do that, we just put low over here and we repeat the same checks. Now in the next iteration, when we compare 1 and 5, we see that 5 is greater than 1, so we have a possibility to attain a profit. So at this point, this is when we can actually buy low and sell high. By doing so, we get a max profit of 4. Why? Because 5 minus 1 is 4. And we continue to do the checks. So can we shift our high pointer when we move our high pointer to position 3, or when we slide our window to position 3? We see that 3 is actually less than 1, so we have a potential to make a sale here. And when we do so, the profit that we get is going to be 2, and our max profit is actually 4 right now, so we don't need to update this value. And if we shift our high pointer again, we see that 6 is still greater than 1, so this is a valid shift. And when we do the shift, our max profit, or the profit attained from doing this shift, is going to be 5, because 6 minus 1 is 5, and that actually forces us to update our max profit value to be 5. So now our global maximum profit is 5, and we do one more shift here, and we compute that next profit, right? And when we do so, our next profit is going to be 3, because 4 minus 1 is 3, and 3 is not greater than our current maximum profit, so then we know that the maximum profit that we can achieve from this array will be 5. And why? Because 6 minus 1 is 5. So for this code, what we need to do is have a max profit value to keep track of our the maximum profit attained. And we need 2 pointers, a low and a high pointer for our sliding window. So now we want to go while high is less than the length of our prices. We could say if prices at low is less than prices at high, right? This is a condition that allows us to buy low and sell high. If it is, then we do so. Let's say profit is equal to prices at high minus prices at low, and we want to update our max profit based on this condition here. The max profit is going to equal to max of what we've seen so far and what we have currently. So if at any point in time our prices at low is the opposite of this condition that we just defined over here, we know that we found a new global minima, so we now need to shrink our window from the left side or update our low pointer. So if prices at low is greater than prices at high, we found a new global minima. Then we need to update our low pointer to where our high pointer currently is. Otherwise, we just need to continue to increment our high pointer until we traverse all future days. High plus equals 1. And at the end of this, we just need to return max profit as a question asks for. And based on this solves this question in linear time. And let's run the code and see how functions. So I run the code, it passes both test cases, and if I submit the code, it passes. So let's do a quick rundown of the time and space complexity here. So as I said, this is a linear solution because we're only shifting our pointers based on certain conditions here, and we're only going through our array once in worst case. The space complexity here is going to be constant because we're not using any auxiliary data structures. We're simply just having variables to keep track of our pointers and our max profit. So our time complexity here is going to be O of n, and our space complexity here is going to be O of 1. So I hope this answered any questions you might have had about this problem. If you still have any doubts about this problem, please don't hesitate to leave your questions down below, and I'll be prompt to respond to whatever questions you might have. Don't forget to hit the like button, the subscribe button, and have a great day.